Okay, so good morning, everyone. Welcome back to Math 115. I'm starting a little bit early today, just to give a little extra time for the review. We're going to come back to the announcements once 8:30 rolls around. So I hope that you all have started your studying for the exam, and I guess that from your time doing the homework, or from your quizzes, or from your confusion during lecture at various points, that you have some things that maybe you'd like to discuss in a little bit more detail, or maybe go back over. So I have some ideas of some things we can talk about, but before we do that, I'd like to ask you all if there's anything in specific that you'd like to talk about. Gavin?
Possibly isolating the root of like the quadratic equation.
Sorry?
Isolating the root of like what goes into a quadratic equation.
Okay, so solving quadratic equations. All right. Did you have one, Chris?
Yeah.
Oh, Morgan.
It was just like one question. Like, I just saw it on the homework class, or like in the last thing. Will we have to find like the y-intercept with like the fraction as a slope?
Okay, sure. All right, and then any other like broad topics that people want to discuss today?
I just have a question about the exam also.
Yeah.
Like, will some answers have to be like in fraction form, or like as long as it's like the correct answer?
Let me hold that question for a minute until 8:30 starts, so everyone's here. Anyone else? Yep.
When like the the square root, not square root, but like it has another number other than square, like 6 root or something in the denominator, how you...
Okay, rationalizing the denominator when we have a higher order root. Okay, got it. Yeah, we can try that as well. Yeah, Chris?
I had a couple of questions on that Coach 7.
Okay. Anything else that we're going to cover today? Okay, cool. Well, if you think of anything as we go along, then feel free to speak up. I'm just going to address the questions in the order that they come. So maybe I'll make a new note. Oh God, that's blindingly bright. Let's make it dark mode. There we go. Isn't that so much better? Yes. Okay. We'll use white today. So today's the review. So first topic, solving quadratics. Well, solving quadratic equations, I should say. So we basically have two methods. Method 1 is factoring and the zero product property. Okay, factoring and the zero product property. So let's see if I can come up with a good one here. You want to do one that's just a regular x squared, or you want also there to be a number here?
Well, my issue is just like getting into a quadratic equation. I guess that makes sense. Like, for example, like when I was on quiz, basically, I had an issue with that one, for instance.
So I think the one on the quiz was a quadratic inequality, right?
Yeah, that's what I meant. I'm sorry.
Okay, that's fine. We can go over that quiz problem. How about that? Okay. Well, we still basically use factoring in the zero product property. So let me delete that for a second and say, okay, we're going to say not solving a quadratic equation, but solving a quadratic inequality. By the way, anyone need their quiz? Lakin, I think I have yours here. Can you come up and get it?
Yeah.
Thanks. All right. So for this one, we had x squared plus 5x minus 14 is less than or equal to 0. Okay, so the general strategy for solving a quadratic inequality is going to be the following. First, we're going to solve with an equal sign. And second, we're going to use the test point method. So let's address how we do the solving part. So we write down x squared plus 5x minus 14 is equal to 0. Okay, is equal to 0. So to solve this, all we have to do is factor. Now to factor, or we can solve this in two methods. So one way to solve it would be to factor and use the zero product property. So what would that look like? Well, we want to find two numbers which multiply together to get negative 14. But if you add them together, I get 5. What are my two numbers? It's negative 7 and plus 2. Okay, now I did that pretty quick. Are there any questions on how I did that factoring process? Okay, then I'll move on. So we set that equal to 0 because these two things are equal to each other. So I rewrite the left-hand side and then I leave the right-hand side alone. So now I have two numbers being multiplied together. Okay, if I multiply something like 3 times 2, I'm never going to get 0. Okay, the only way I'm going to get 0 is if one of the two numbers that I multiplied was 0, or both, right? But of course, both of these can't be 0 because if x is 7, then this one will be 0, but this one will be 9, right? So this, if x equals 7, then what do we get? We get 0 times 9 equals 0, and we're all happy. Or if x equals negative 2, for example, then we get what? Negative 2 minus 7, that's negative 9. And then we multiply that with 0, and that's equal to 0, and so we're happy. So that's what the zero product property says. So we get here, we can just solve, well, we just solve where each of one of these is set equal to 0. So x minus 7 equals 0, or x minus plus 2 is equal to 0. And therefore, either x is equal to 7 or x is equal to negative 2, right? Okay, that's one method. Let's say that you don't know how to factor. You can always use the quadratic formula. So what does it say? It says that x is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, right? So in this case, that would be our a is 1, b is 5, and c is what? It's negative 14. Okay, good. So let's go ahead and do this. So b is 5, c is negative 14. So we get negative 5 plus or minus the square root of 25 plus, because c is negative, 4a is just 4, and then 4 times 14 is 28 times 2 is 56. Did I do that right? Have I done something wrong here? I feel like this is not going to work out. Okay, 25 plus 56, what do we get? It's 81. Yeah, you're right, it is going to work out. So this is 81, and then we divide, of course, by 2a, which is just 2. So then what would we get? We get x is equal to negative 5 plus or minus 9, right? Plus or minus 9 over 2. So x is either equal to negative 5 plus 9, that would be 4 over 2, which is 2. Have I done something wrong here? We've definitely done something wrong, right? It's because I factored wrong on the left-hand side. It should have been x plus 7 and x minus 2, shouldn't it? Right? Because we want plus 5 when we add them together. So that would make this a little bit different here. That would be x plus, and then this would be x minus, and this would be negative 7 and positive 2. So, okay, we get x equals 2, or if we subtract 9, then we'd get negative 5 minus 9 is negative 14 over 2, which is negative 7. Okay, good. So those are two methods which you can use to solve with an equals sign. But now we're not done, are we? Because we're not solving the equality. We're supposed to solve the inequality. So all we do now is use the test point method. So what I do with the test point method is I solve with an equal sign, and I put those on a number line. So I'm going to put on my number line -7 and 2. Okay, and now what do I do? What am I supposed to do now using the test point method?
Pick a number from each section and plug it into the original inequality.
Okay, so pick a number from each section and plug it into the original inequality. How do I know what numbers to pick? Well, it's up to you, right? You can pick whichever ones you want. But I like to pick numbers that are going to be easy to plug in, which if I'm going to be plugging into this guy, I'm going to have to do a square. So I don't want to pick any numbers which are too big so that I don't know how to square them, for example. Okay, so I'm going to pick easy numbers. I like -8 and probably 0 and then 3. Okay, nice, even, or not even, but whole numbers. And I like to incorporate 0 when I have the opportunity. And now I'm going to test. I plug 8 in. And I get 8 squared. What is it? Plus 5 times 8. Sorry, -8. Quantity squared. Times plus 5 times -8. And then minus 14. Okay, so I get 64 minus 40 minus 14, right? And I get, if I subtract 54 from 64, I believe I get 10. And the goal is to check whether this is or is not less than or equal to 0. Well, I put a less than or equal to 0 sign here. Does this make sense? No. This is not true, so we get false for this region. Therefore, I'm not going to shade it, okay? Now let's try 0. So if I plug 0, I get 0 plus 0 minus 14 is less than or equal to 0. What do we think? I think yes, that's true. -14 is less than 0. So it's true in this region. And I'm now going to plug 3. If I plug 3, I get 9 plus 15 minus 14 is less than or equal to 0. I think that's 10 is less than or equal to 0, right? What do we think? It's false. So I'm going to put false here. And I'm not going to shade. So where am I going to shade? I'm definitely going to shade in between here, right? So is there anything else I need to consider for this problem? Yeah?
It's greater than or equal. It's greater than or equal to kind of thing. It's equal to.
That's right. I've left something off of my graph here, right? Namely, I should have either a circle, open circle, or a closed circle at -7 and 2. Which one is it going to be? It's going to be a closed circle. The reason it's going to be a closed circle is I want to find all of the numbers which make this inequality true. If I plug in -7 to the inequality, what do I get? I get, well, -7 is one of the roots of the quadratic. So if I plug -7 in to this equation, what do I get? You don't even have to work it out. What is it going to be? 0, right? Because that's the whole point of this process. We solved all of the ones where it's equal to 0. We found the numbers which make this 0. So is 0 less than or equal to 0? Yes, 0 is less than or equal to 0. So I'm happy to put a closed dot on 7 and on 2. Okay, so that's how we do that. And finally, I need to give my solution set in interval notation. Now, the solution set is of course, all of the numbers that make the inequality true. And I'm supposed to do it using interval notation. So how do I convert this graph into interval notation? What will I get? Yeah, negative 7, 2 in brackets. Very good. I use brackets because I have closed dots. And all of the numbers in between negative 7 and 2, if I plug them into this inequality, it will be true. That was our goal. Okay, so that's a rational inequality. It comes down to using the test point method. So to use the test point method, the crucial step is to first solve the inequality with an equals sign. With an equals sign. And then plot those points on the number line and then pick a test point from each subregion to plug into the original inequality. Any questions over this problem that was on our quiz? Yes?
So if it's greater than or equal to, as long as the equal is there, we know that we're using closed dots. But if it's not there, are there any scenarios where you have a bracket and a parenthesis, or will it just be like 2 parentheses, 2 brackets? Because I messed that up, so that's why I was...
Well, you could have a parenthesis and a bracket if you had, say, a compound inequality. So if you had something like x is... Why don't we do one of those? What if we had x plus 3 is less than 7, but greater than 2, or equal to 2? Something like this. We could definitely get a mix and match, right? So what would we do? How would we solve this if we wanted to put the solution set in interval notation? What would we do for this guy? Subtract 3. If I do it in the middle, where else do I have to do it? On both of the other sides, right? So I'm going to subtract 3 here. I'm going to subtract 3 here. And I will get what in the middle? Just x, and then less than 4, and then greater than or equal to negative 1. Okay, so let's do it on a graph. What would I do? I'd put negative 1 here, and then 4 goes to the right of that because it's a bigger number. And then where do I shade? I got 2 options, right? I mean, one is to shade here and here, okay? And then the other would be to shade in the middle. But I should do it in the middle, right? Because we want x to be a number which is smaller than 4 and bigger than or equal to negative 1. So I'm going to shade in the middle. And what goes at 4? A closed dot or an open dot? Open dot. And how about at negative 1? A closed dot. And so if I was going to write that using interval notation, what would it look like? It would look like negative 1 comma 4 with a parenthesis on one side and a bracket on the other.
But that would never come up during using the test point method, though, right? That's what I was trying to figure out. Using the test point method, you would ever have that scenario.
The only scenario where that could... Well, okay, it could come up if you had a compound test point inequality, but that's maybe too complicated for an exam.
Okay, perfect.
So if you had something like less than 0 but larger than negative 5, something like that, maybe you could have something like that. Or if you had a rational inequality, then the denominator is always going to be an open dot, whatever makes the denominator 0. But I'll tell you now, I'm not going to put a rational inequality on the exam. All right, so before we move on to something else, let me quickly talk about the exam since now everyone's here. Where did I put that? Oh yeah, here it is. So today's class is a review, obviously. So I just want to remind everyone about the exam, which is going to be tomorrow, I think. It's Tuesday today, right? So tomorrow will be September 14th, Wednesday. The exam covers sections A.1 through 1.3. And I have written the exam now, and it is 3 pages long. And basically each page has like 3 questions on it, or something like that. So it's basically like 3 quizzes stapled together is how long it is. My goal is for it to not take everyone a super long time, so it should be, I hope, fairly straightforward in terms of like you should have plenty of time. in terms of the content on the exam, I basically was able to work it out that there's one question from each of the homeworks from 8.1 up to 1.3. So not including the ones where there's like A, B, C for that. So there's one question from 8.1, there's one question from 8.2, there's one question from 8.3, and so on and so forth. Obviously, all those sections have a lot of content in them, so it's kind of, I tried to select something representative from each section. Nothing should surprise you as long as you've done the homework. Everything is, all of the exam questions are pulled directly from the homework with minor adjustments. And to answer Morgan's question from earlier, which was, are there going to be any, like, fractions? Well, what was your question again?
It was like two, the one was, well, the one was like, does it matter like what form it's in for the answer, like fraction?
It will always be specified. If I don't specify, fully simplify your answer, then you don't have to.
The other one was if we're to find the y-intercept with a fraction as the slope.
Will you have to find the y-intercept with a fraction as the slope? I don't think I can, that answer is a little bit, or that question is a little bit too specific, I think, for me to answer.
I think it might have been homework last night, so I don't think it would matter anyway. I think I just wrote it down.
Okay,
It wasn't. Yeah, it wasn't.
It was just like, never mind.
It would give us like a point and the slope would be like, find whatever.
I
You
just
have to
kept
use
getting
them-
it wrong. 'cause
You
it
don't have
was
to use
like
points. You just have to
fraction.
like add or subtract fractions, which is not that bad.
Yeah. And it was like fractions
Like I
specific.
could literally show you the problem.
okay, well, I will say this. Adding and subtracting fractions and also multiplying fractions is a important skill to know how to do. The context in which you might need to do that, I won't reveal. But there will be a tiny bit of fractions on the exam. But for the most part, you won't have anything crazy like, 37 over 51 or like, none of the addition or multiplication is going to be outside of the realm of what you would do in elementary school, basically. Does that answer your question? Okay, so that's the exam. Also, my office hours today will be from 2:30 to 4 p.m. in LeConte. We may move rooms. I might be on the 3rd floor, depending on how many people come and the availability of classrooms. But for some reason, they haven't gotten LeConte all the way onto the reservation system, so I'm not able to actually reserve a room. We're just going to have to play it by ear, as it were. So I'll leave a note on my office door. So if you go to my office door, you should be able to find the room that we're in, and I'll also probably send an email to you all. If
Room on Blackboard just in case.
Sorry?
Is the room like when you? Sorry, let me rephrase that. Is the office room like on Blackboard so I can just, or should I just write it down?
You should probably just write it down. Yeah, LeConte 439.
That was so impressive.
But you can also find it on, if you just go to the 4th floor, my door has my name on it, so you can just walk around until you see it. All right, also the Tutoring Center, okay, is in LeConte 102, so if you can't go to office hours, that's where I recommend you to go, LeConte 102. You can go there from 10 a.m. to 3 p.m. Okay, any other questions on the exam before we go back to review? Okay. Who was next that I hit? I think Morgan, you had one, right? A homework problem or something.
Yeah, but you kind of covered it.
I kind of covered it already. Sweet.
In my question.
Perfect. All right, then who was next? Maybe it was Sully. What did you say? Oh yeah, rationalizing denominator with roots. Okay, why don't we actually even just go back over a bunch of exponent rules? That would probably be worth our time, because that's something that I noticed a lot of in terms of the quiz, is we definitely need to make sure that we have our exponent rules down pat. So there's only like 6 or 8 of them, so I'd recommend putting them all on a flashcard if you haven't already done so, and just memorize those because they're definitely an important skill. So what's the first one? It says that x to the n is defined to be just x times x times x dot 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 times x, where I have n of them. Okay, how about x to the minus n? How do I define that? I define that as 1 over x to the n. And x to the n is defined above, so I won't write this out again, but it's 1 over x to the n. All right, how about x to the 0? What's that going to be? 1, no matter what x is. Okay. How about x to the m times x to the n? What do I get? Okay, it's x to the m plus n. Okay? Not to be confused. Not to be confused with. Not to be confused with this rule. X to the a. Not to the a. Why don't I do x to the m? To the n. Not to be confused with x to the m to the n. What do I get when I do that? I multiply the powers, okay? These two rules were confused by students on the exam by about like 50% of our students in the class. So this is definitely something that I would probably recommend you spend some time making sure that you have the difference between these two down. And it's not hard to see why if you just write it out. X to the m times x to the n is what? X to the times x dot 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 times x, where we do that m times. And then we multiply again by x times x dot 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 times x, where we do that n times. So if you just write it all out, you can see exactly how many x's I have. I have m plus n, right? For example, what is x squared times x cubed? Well, that's x times x for x squared times x times x times x, right? And then you just count them up. 1, 2, 3, 4, 5. Okay, so 2 plus 3 is 5, right? All right, what if I did x squared cubed? What would that look like if I wrote it out? It would be x times x, and then times x, and then times x, right? If I write it out like this, which is exactly what it means to cube something, you take whatever's inside, multiply it times itself 3 times, count up all the x's. 1, 2, 3, 4, 5, 6. All right, so now I get x to the 6th. So if you ever forget, you can always just write these two examples out. That took me about 20 seconds or 30 seconds. And you can see exactly what the rules are fairly easily. This will help you to remember if you forget. Okay, so those are some rules so far. Let's see, what other rules do we have? What if I do x to the m divided by x to the n? I subtract the powers. Okay. X to the m minus n. Okay. Does anyone have their My Math Lab open right now? Can you go to the homework on integer exponents, which I think is 8.1, and then yeah, it's hard to go back and review, isn't it? It's kind of annoying.
It's not that bad, it's just you would have to figure it out first. Is it B or, yeah?
It should be B, integer exponents. And just click through that and find the hardest problem that you can find on there for me while I go through the rest of the rules.
Are you sure you want me to do I like number 1.
Let me see if there's any exponent rules that I missed. Oops, that's polynomials.
This one's hard.
Okay, I missed a couple, so let me go over these first.
7.
Okay, so 2 more that I missed. I've also got, what if I do x times y, and I do all of that to the 4th power, or to the nth power? What do I get when I do that? Yes, I get x to the n times y to the n. Okay? It's a bit of a misnomer to say this, but you can, if it helps you to think about it, we're distributing. Okay? Which is definitely a misnomer, but what would we get if we did this out? If we wrote it out, it's not hard to see. You'd get x times y times x times y times dot 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 times x times y, right? Count up all the x's. How many do we have? N. Count up all the y's. How many do we have? N. That's how we get this. Okay, what if I do x divided by y and I take all of that to the nth power? What do I get? I get x to the n over y to the n. Okay, so let's do a couple examples now. You got us?
7 is not that hard, but I thought it would be a great one to go over.
Okay, let's do it.
7 cubed times -1 exponent.
No, it's like in parentheses.
It's like
No.
No.
7 cubed quantity to the negative 1.
I see. Like this?
I wrote it down. Yeah.
Okay, so let's see. How would we simplify something like this? Which one of our rules are we going to use? Okay, we've got what? We have 7 to a power, to a power. Let's go back and find the relevant rule. Which one is it going to be? I think we need the rule here in blue, right? That's kind of what it looks like. We've got a number to a number to a number, right? So let's just reference the rule. What does the rule tell us to do? Well, it says to take those 2 powers and do what with them? We should multiply them, right? So in this case, let me ask you, is there a problem with doing this when we have a negative power? Is there a problem? Is that gonna stop us from applying that rule? No, because I can still multiply a negative number with a positive number. What would I get if I multiplied those 2 powers? I get -3. And am I done? No, what do I still have to do? I need to use the other rule, okay? When our final answer should never have negative powers in it, okay? Our final answer should never have negative powers. So how do we address that? Well, we have a rule which says when you have a negative power, you can rewrite it as a positive power by moving it to the denominator. Okay, so let's go ahead and apply that rule. What would I get if I used that rule? 1 over 7 cubed, right? Okay, and now I'd say I'm done. I'm not going to ask you to cube 7 on the exam. That's too much multiplication.
Will you say, like, don't solve, just simplify, so that we remember that?
Okay. There are some rules which we should always obey, which is namely our final answer should have no negative exponents and no fractional exponents in the denominator. Okay, that's one thing that is just going to be consistent among all of the problems. But generally for these problems, what I'll do is I'll write something like fully simplify the resulting expression. That's word for word from your exam. Or, yeah, the expression, the instructions I think you will find are exceedingly clear. And if you feel like they're not clear, then that's my fault. And you come to my office hours and say, hey, idiot, you weren't clear with the instructions here. Give me my points back. And I'll do so, okay?
9 is also hard.
All right, let's do another one. 9. What does that one say?
Someone else say it out loud. I'm not good at that. So hard. I can't dictate math.
41 to the -2 plus, and then in parentheses, 1 over 41 squared.
Okay.
No. Okay.
Like so?
No, like 41, like the squared is like outside.
Okay. The way I like to say that is I'll say 1 over 41 quantity squared. So to refer to the quantity 1 over 41 all being squared, I'll say quantity squared. Okay. How can I handle something like this? Well, let's start with the first part. 41 to the -2. Any simplification needed there?
Yes.
Yes. What rule? Negative power. What does that mean?
1 over 40.
Means 1 over 41 to the power, what? Positive 2. Okay, move it to the denominator, make it positive. How about the second thing? How can I rewrite 1 over 41 quantity squared?
You can square the 1 and the 41 individually.
Exactly. I can do 1 squared divided by 41 squared. What is 1 squared?
1.
It's just 1, so I'm just going to write 1, okay? All right. Am I done? No. What can I do? You can add them, right? What do I get? I have a common denominator between the two. So I just add the numerator with the numerator, and the denominator becomes what? Just 41 squared. It stays 41 squared, okay? Okay, so that's another one. Can you see if there's a one that goes something like 6x cubed y to the 7th over like y cubed x to the -2 times 3? Why don't we just do that one, actually? Okay, so this one's more complicated. How do I deal with something like this? First of all, is it a problem that in the numerator it goes number and then x and then y, and then in the denominator it goes y and then x and then number? It's not a problem, because why? We can do multiplication in any order that we want, right? 3 times 5 is the same as 5 times 3, yes? So we can do multiplication in any order that we want. So one thing that I find is usually helpful for students when they start a problem like this is to rewrite the denominator in the same way as the numerator, or vice versa, right? So I'm going to rewrite. I'm going to write 6x cubed y to the 7th, and I'm going to divide that by 3 x to the -2 y cubed. Okay, this is perfectly fine, because this and this are the same thing. Y cubed times x to the -2 times 3 is the same as 3 times x to the -2 times y cubed. Okay, so now what I do is what? How do I simplify this?
Well, you can do 2 over 1, right? Like the rest of it.
Yeah, I can simplify basically the following. I can simplify these two with each other, I can simplify these two with each other, and I can simplify and I can simplify these two with each other, okay? In fact, if it helps you, you can rewrite this expression as 3 fractions. 6 divided by 3 times x cubed divided by x to the -2 times y to the 7th divided by y cubed. Okay? We can rewrite like that. Okay? That's perfectly fine. Why? Because what do we do when we multiply fractions? I multiply the numerator with the numerator. I multiply the denominator with the denominator. If I do that twice, then I, of course, just get what I had before, right? But the reason that sometimes I find it's helpful for students to write it out this way is it's easier for them to see how each one is going to simplify when they're separated out like that. Okay, so who can help me with 6 over 3? What do I get? Just 2 over 1, right? And then x cubed over x to the -2? X to the 5th in the top. Okay, someone explain what happened there.
Since it's -2, you add it.
Since it's... Okay, you could think about it in 2 ways. You could think about it using the rule that x to the m over x to the n is, of course, just x to the m minus n, which in this case, if we have m equals 3 and n equals negative 2, then we would get x to the 3 minus negative 2, which is, of course, x to the 5th. That's one way to think about it. The other way to think about it would be to say that x to the m, the other way to think about it would be to say that x cubed over x to the negative 2 is the same as x cubed over 1 times 1 over x to the negative 2, which is x cubed over 1 times 1 divided by 1 over x squared. If I divide by a fraction, it's the same as multiplying by the reciprocal. So this is x cubed over 1 times 1 times x squared over 1, which is just x cubed times x squared, which is x to the 5th. Your way was easier, huh? Okay, so yes, in general, I think it's easy for people to see, okay, yeah, negative 2, it needs to go to the top, it becomes a 2, so I just add 2 and 3, right? But if you want to know, like, the real mathematical proof of why it's happening, then you can write all that out. So I don't know if that's that helpful, but the idea is basically, if we have a negative power in the denominator, we add that power to whatever power we have in the numerator. That's basically the rule. Or if you want to think about it, we're subtracting the negative power, which is the same as adding. Okay, so now how do I deal y to the 7 over y cubed? Yeah, I use the subtraction rule. So this becomes times y to the 4th. What are the denominators for each of these, by the way?
1.
They're 1. Very good. Okay, so in the end of the day, I get 2x to the 5th, y to the 4th. Now, this is simplified. Why? Because I have written everything as a single power of x and a single power of y, and those powers are, I don't know why that keeps happening. Those powers are positive. Okay? All right, now let's see one more rule here, which is fractional exponents. What does it mean if I write x to the m over n? What does it mean if I write x to the m over n?
The square root.
There's going to be a root involved, but it might not necessarily be a square root, right? It could be an nth root, for example, right? So in this case, the denominator, right, represents the root, okay? Here's how you can see that. You can rewrite this as x to the m to the 1 over n, right? And the 1 over n power is the same as the nth root, right? So this is x to the m being nth rooted, okay, if you want. Okay, so let's see an example of some stuff with fractional powers. Okay, what if I were to give you something like this? X to the 3/2 divided by x to the 1/4. How should we deal with something like that? Well, I want to write this as a single power of x, and it should be a positive power, and I shouldn't have any fractional powers in the denominator. How can I deal with something like this? How would I simplify this? Any rules that I might want to apply? The subtraction rule, right? If I have x to a number divided by x to another number, what do I have to do? I can rewrite this as x to the first number in the numerator minus 1/4, the number in the denominator. Okay, now what do I have to do to simplify this? I need to perform this fraction subtraction. Okay, so how do I subtract 1/4 from 3/2? Sully already told us we need to find a common denominator. So I'm going to rewrite x, and how am I going to rewrite 3/2? 6/4. Very good. I multiply the top and bottom by 2. Minus 1/4, which is what? X to the 5/4. Okay, if I have a common denominator, you just subtract the numerators from one another. Okay, so that's how I would simplify something like that. And notice, this is perfectly fine. So one of the things that I feel like you might have been getting at with your question, Sully, was, well, should I start this problem by, say, multiply the top and bottom by x to the 3/4, right? Because then in the denominator, I would get a power of like 1. You see what I mean?
I was talking about like having roots that are like we did one in the notes.
Mhm.
And it was
Probably something like, how do I rationalize the denominator if I have 1 over the cube root of x? Something like that?
yeah.
Or cube root of 4, or whatever. Is this what you were talking about?
Yeah, like yeah, I don't know where it was in the notes, but it was something like that.
Okay, so the question is, how do I rationalize the denominator when I have a cube root instead of a square root? Or an nth root instead of a square root? Well, what I need to do is I need to multiply the top and bottom, not just by the cube root of 4, but I actually need to do that twice, and here's why. What I need to do in the denominator, okay, is I need to get rid of the root, which the root is a cube root. The only way that you can undo a cube root is by cubing, okay? So if I have 3 cube roots, all of the same type, being multiplied together, then what do I get? In the denominator, I just get 4. And in the top, what do I get? I get the cube root of 4 squared. Or if you want, the cube root of 4 quantity squared. Both are okay. Does that answer your question? Okay, so here's another way you could see that. Because, of course, we know that a cube root is nothing but a 1/3 power. So you could rewrite this as 1 over x to the 1/3. Okay, and then you could say, well, if I want to rationalize that denominator, what I need to do really is make this power to be 1 in the denominator. I need to make the power in the denominator to be 1. So I would do that by multiplying the top and bottom by x to the 2/3, right? Because then if I multiply the denominators together, what do I do with those fractions? Add or multiply? Add, right? Because I'm multiplying 2 different things with different powers. So I would get x to the 3/3 in the denominator, and then in the numerator I'd have x to the 2/3, right? And x to the 3/3 is nothing but x. So now I've rationalized the denominator. So I think I was kind of answering your question, Sully, but just in a little bit of different language. Okay, so we can always view nth roots as fractional powers, and vice versa. Okay, I think that might be all that I want to say about exponents for today, unless anybody else has an exponent problem that they wanted to talk about.
I
Yep.
have a question on that. Like, does it matter if it's like in that root form or like a fraction on the answer? Like, you know how like we want to do
I'll specify. Yeah, I'll specify. Any other questions on exponents, or anyone have an example that they want to work through for exponents? All right, then let's move on to a new topic. We talked a lot about exponents here, which I think is a good use of our time. What else should we talk about today? Haley?
Can you go over completing the square root of the equation of a circle?
Absolutely. So the question was, how do I complete the square for a circle? So let's maybe start by talking about what a circle is. So I'm just going straight back to our notes, by the way. You can find these on the blackboard. I'll post an updated version later today. So a circle is, of course, a set of points, okay? It's the set of points highlighted in red, okay? So all of these points on this circle have an ordered pair associated with them. And what's true about all of those ordered pairs x comma y is that they satisfy this equation for some numbers h, k, and r. Okay, that is what a circle is. And loosely speaking, this is like a quadratic formula. This says a squared plus b squared equals c squared. Not quadratic formula, excuse me, Pythagorean theorem. Right? This is the Pythagorean theorem. A squared plus b squared equals c squared. Okay, it's just that I'm using different letters. And that's because we're talking about all the points that are a fixed radius away, right? So I just choose a direction and I walk however far the radius is, and the collection of locations to which I could walk is what we call the circle. So that's the definition of a circle. And of course, the circle has standard form x minus h squared divided by, or plus 1 minus, Jesus, I cannot speak, x minus h squared plus y minus k squared equals to r squared, where the center of the circle is found at the ordered pair h comma k, and the radius of the circle is r. Okay, so one thing to keep track of is this is r squared, okay? So the radius isn't going to just be whatever's on the right-hand side. We have to take the square root of that number. All right. So what Haley's getting at is, okay, that's great. When we have it in standard form, it's really easy to see how do we graph this thing. We just go to HK, we put the dot, and we draw our radius out, and then we make the circle, right? Easy as pie. No pun intended. So the question really comes down to, okay, what if they tell us that something like this is the equation of a circle, right? Something like this is the equation of a circle. I can't tell where the center is by looking at this equation. Maybe you can if you're like Einstein or something, but I can't. So what we have to do is convert this equation. We're going to manipulate it until it looks like this equation. That's what we want to do. And the main tool that we have at our disposal for doing that is called completing the square. So let me discuss what completing the square is, and then I'll do a couple examples. So completing the square is when we have a term which looks like x squared plus a number times x. We want to rewrite this as something like x minus h squared. Okay, we want to rewrite this as something like x minus h squared, and then maybe minus some other constant, right? Maybe minus some other constant, or plus. Okay, that's how we want to rewrite it. So to do that, we introduce an additional term, okay? What we do is we take that b number, whatever that number is that goes with x. We divide it by 2 and then square it. Okay, divide by 2 and square it. And we take that number and we add it and subtract it. Okay, if I add and subtract, I haven't changed anything. Okay, I haven't changed anything. And then what you can see is that this here is exactly x plus b over 2 squared. Okay, so then I can rewrite x plus b over 2 squared from this term here. And I'm left with this residual minus b over 2 squared. Okay, so let's see how that works. Let's complete the square a couple times. Okay, so complete square. X squared plus 3x, plus, why don't I do 6x? How do I complete the square? Someone help me out. I want to add something and subtract the same thing so that I don't change anything. What do I do to get that number? I take this number, 6, and what do? Divide it by 2 and square it. Okay, so let's take 6, divide it by 2, and square it. And I'm going to add and subtract that. Okay, so this is the same as x squared plus 6x plus 9 and minus 9, right? Okay, so now my goal is to just rewrite this. So let's use factoring to rewrite that. I want a number that if I multiply it with itself, I get 9, and if I add it to itself, I get 6. What is that number? It's 3. So I could rewrite this as x plus 3 times x plus 3. Do you agree with me? And then minus 9 still. And then x plus 3 times x plus 3 is just x plus 3 squared, right? Are we happy? Okay, let's see another one. Or I'll leave that up there for a second. Any questions on this one? Yeah?
Did you not do the y side as well? I think for the top equation, there was also y squared and all that stuff, was not.
Yeah, we would, but right now we're just practicing the method. We'll get to that in a second. So let's try another one.
What was the homework that had the solving for circles?
1.2, I think. Okay, let's see another one. What if I had y squared minus 18y. Let's try to complete the square for this one. Okay, so my first impression of this is, holy crap, I only ever learned how to complete the square with x. What is this y doing here? Well, it doesn't matter what the letter is, right? It's still just a variable, okay? So I don't want anyone to be confused if we have to complete the square with y or with t or with alpha or whatever, right? So how am I going to complete the square here? What am I supposed to do every time I complete the square? I take that middle number, divide it by 2, and square it. What is the middle number in this case? Is it 18? It's negative 18, right? It's negative 18. So let's take that number, and what do? I divide it by 2, and I square it. And I'm going to add and subtract that number. Okay, what do I get if I do negative 18 divided by 2? Negative 9. And what do I get if I square that? Positive 81, right? So this is the same as y squared minus 18y, and then plus 81, and then minus 81. Agree? Okay. Now someone help me finish this off. What do I have to do still? I have to factor. Do I factor the whole thing? No, just the 3 terms on the left, right? Left, right. Okay, that's confusing. Just these terms. So how do I factor that? Y minus 9 squared. Okay, if you want to write out y minus 9 times y minus 9, that's fine. But I think it's easy to see that it's going to, of course, be a square term because that's our goal, is to create a square term. So if you FOILed this, y minus 9 times y minus 9, then what would you get? You would get this. Okay? All right, so that's how we complete the square for this one. Any questions on this one? Okay, so one thing that you'll notice is that whether or not we have a negative, okay, as the b, the process is still the exact same. We add first b over 2 squared, and then we subtract second b over 2 squared. Okay, doesn't change just because we have a negative sign. All right, so let's do a circle now. Let's do the one that we had in the notes, just because I know that one's going to work out. And I'll add another page here so we have more room to work. Okay, paste. Find the center and radius of the circle. hand graph. Okay, how do I start? Yeah, I like to reorder the terms. Okay, I like to put all the x's together and all the y's together. Okay, so I'm going to do that now. X squared minus 6x, and then I'm going to leave a blank because I know I'm going to have to complete the square. And then I have a plus y squared plus 8y, and then I'm going to leave a blank because I know I have to complete the square. And then I'll have a plus 10. Actually, I'm going to move the 10 over because it doesn't need to be there. Equals negative 10. Okay, so now I want to complete the square with both of these expressions, right? How do I do the first one? You take the middle term, you divide it by 2, and square it. So negative 6 divided by 2 is negative 3, and square that, you get 9. So I'm going to add and subtract 9. How about the second expression? Same process. Divide the middle term by 2, so that becomes 4. If I divide 8 by 2, I get 4, and then I square that and get 16. So I'm going to add 16, and I'm going to subtract 16. Now what's my goal? Factor just this term and this term, right? And I'm going to leave those minuses hanging out, because eventually they're going to go over to the other side, okay? All right, so what do I get when I factor the first expression with x? I get x minus 3 squared plus this one? X plus 4 squared? Not minus 4. It should be y plus 4 squared, right? Y plus 4 squared. Because this one's with y. Okay, this one's with y. And then equals to negative 10 plus 9 plus 16. Okay? So I think that's the same as 15. Okay. So, what is the center of the circle? That's right. Very good. It's 3, negative 4. Okay, hang on. I did this in my head, and I got negative 3, 4. What did I do wrong? The standard equation of a circle already has a minus sign in it. Right? It already has a minus sign in it. Okay, so if I have something like x minus 1 squared plus y minus 2 squared, then the center is at 1 comma 2, okay? 1 comma 2. Or if I had a plus 2 here, then where would it be? 1 comma negative 2, right? Because subtracting a negative is what I do when I'm adding. Okay, so let's finish it off. Where did I go? Here I am. Okay, so the center is 3 comma negative 4, and the radius is just 15, right? No. I have to take the square root, right? I have to take the square root of whatever is on the right-hand side. This is r squared, okay? So r is the square root of that number. Okay, so that's the center and the radius. So let's graph which quadrant is the point 3 comma negative 4 in. We got 1, 2, 3, and 4. It's in the fourth quadrant, right? Because I go to the right 3 and down 4. Okay, to the right 3, down 4, probably like here or something like that. So that's 3 comma negative 4. And how do I draw a radius of square root 15? Yeah, it's going to be between 3 and 4, right? Because square root 16 is 4, and square root 15 is a little bit less than that. but it's more than square root 9, which is 3. Okay, so it's going to be close to 4, which means I shouldn't quite go all the way up, right? Because this length here would be 4. So I got to do a little bit less than that. And then I'm going to draw my circle. And it's not a very good one, but luckily we have the power of technology on our side. I guess really it should look more something like that, right? Yeah, something like that is what it should look like, right? Because it should go a little bit over the y-axis and not quite to the x-axis. Okay. Any questions on that? Yeah.
Are you going to make us draw a circle on the exam?
No, I won't make you draw a circle on the exam. All right. Any other questions on this? Okay. Next topic. Does anyone have any other topics we should discuss? There's kind of a lot. Yeah.
Would possibly mind going over number 3 on the last quiz?
Number 3 on the last quiz. Sure thing. Let's go back to the review. Okay, so number 3 on the last quiz was to solve for t. And it was t minus the square root of 9t plus 40 is equal to negative 6, right? So I have a problem here where I'm supposed to solve for t, and my equation has a radical in it. My equation has a radical in it. What's my approach when the equation has a radical in it? Sully.
To isolate the radical.
You must isolate the radical first, right? So let's go ahead and do that. I can do that in one of two ways. I can move the t over, or I can move the 9t over and then the 6 over, and then everything would be positive. Whichever way you want to do it, I'll leave it on this side for now. So I'll do negative 9t plus 40 is equal to negative 6 minus t. Okay? Negative 6 minus t. Now what do I do?
Square both sides.
Square both sides. Okay? Now here's what I want everyone to be a little bit careful about. Is there was a common mistake was everyone would square both sides, okay? But there were a lot of people who said, okay, if I square both sides, then I get negative 9t minus 40 is equal to negative 6 minus t. Actually, they would say, well, I square both sides, so I get negative 9t minus 40, and also on the right side, they'd say, well, this is just 36 minus plus t squared. That's what they say. What are the two mistakes that I made going from here to here? Let's start with the left side. What's the mistake here?
Asking parentheses, the negative on left.
Yeah, I think it will help if you write some extra steps in between. If I write negative square root 9t plus 40 times negative square root 9t plus 40, then what do I get? The negatives cancel one another. And I'm left with the square root of 9t plus 40 all squared. What do I get if I do that? Not negative 9t minus 40, but what do I get if I square this?
19 plus 40.
Yeah, just 9t plus 40. If I take a square root and I square it, then the square root just goes away. So I get not negative 9t minus 40, I get 9t plus 40. Okay, that's mistake number 1. How about the right-hand side? What was the mistake that I made on the right-hand side? I didn't FOIL. That's right. If I'm going to square this, okay, I can't just square both of the numbers. Okay, I can't just square both of the numbers. What I have to do is write negative 6 minus t times negative 6 minus t okay? And I FOIL. What do I get? 36 plus 6t plus 6t plus t squared, okay? Which is t squared plus 12t plus 36, okay? All right, so step 1, isolate the square root. Step 2, square both sides, okay? Square both sides. And do that correctly. What's step 3 gonna be? Combine like terms. Okay, move everything over to one side. Why do I want to move everything over to one side? Can't I just like solve for t right away? No, I have a quadratic equation. The quadratic equation is only solved when we put 0 on one side. So I'm going to move all of this over to this side. So I get t squared. 12t minus 9t is 3t. And then what? Minus 4. Very good. 36 minus 40 is minus 4. And that's all equal to 0. So now I solve the quadratic equation. I think you can factor it easily or use the quadratic formula. I'm going to factor it. What are two numbers which add to 3 and multiply to negative 4? Very good. Positive 4 and negative 1, right? So in the end, my answer is going to be what? T equals to 1 or t equals to negative 4, right? Did I do that right? I feel like maybe on the quiz it was something different. Did I write down the problem wrong or something?
No, I did negative 4 and 1.
No,
And I did 1 and negative 14. But I got it right.
Let's see, we square both sides, we get 9t plus 40 equals to 36 plus 6t plus 6t, that's t squared plus 12t plus 36. We subtract 9t from the right-hand side, we get 3t, we subtract 40 from the right-hand side. Yeah, this should be correct. Okay, so that's how we solve this equation involving a radical. Any questions on that? Okay, so what are the steps again? Somebody run me through all the steps. Isolate the radical. Square both sides. Combine like terms.
Well, you have to FOIL first, then combine them.
Yeah, exactly. If we square both sides, we have to make sure we do that correctly using FOIL as needed. And then combine like terms and then solve the resulting equation that doesn't have a root anymore. Okay, so like half of the battle is just getting rid of the square root, right? And then once we're done, we got a quadratic equation still left to solve. Any more questions on that one? Okay, if not, then any other questions that we should go through today?
Can you do an example where you like replace the x's with u?
Sure, a quadratic in form problem. Let's go ahead and do that. This is not the notes, is it? This is the review. Okay. So, quadratic in form. So, the thing about equations which are quadratic in form is they'll give us something like x to the 4 plus 2x squared plus 1 equals to 0, okay? And the trick is to see that although this equation is not quadratic, there is a special relationship between the powers of x, okay? They go like x to a certain power plus x to a half of the previous power plus x to the 0, Okay, so here's quadratic in form. Another one could be something like x to the 6th plus 2x cubed plus 1 equals 0. Or, for example, x to the 2/3 plus 2x to the 1/3 plus 1 equals to 0. So what's the relationship? The power goes like 2, 1, 0. You see what I mean in terms of that pattern? Okay, the middle term has power half of the one before it. And the next term has power 0. Okay, so these are some examples. Let's see some more examples, just for fun. How about, I don't know, kind of done them all. We could even do something like this. X to the 4/3 plus 2x to the, what power would make this quadratic in form? Well, the power in the middle needs to be what compared to the power at the start?
Half.
Needs to be half of what it was before. What's half of 4/3? Yeah. Very good. Okay, so all of these are quadratic in form. So what's the goal here? The goal is to do the following. The goal is to take biggest power of x and let u squared equals to whatever that is. So let's see this example for each of these. So in the first one, what are we going to do? We're going to take the biggest power of x. What is it? X to the 4th. We're going to set u squared equals x to the 4th. The second one, what would we set u squared equals to? X to the 6th. How about the next one? X to the 2/3. And the next one? X to the 4/3. Now let's solve each of these for u. What's u going to be if u squared is x to the 4? X squared. Okay, now we're going to need to use an exponent rule here. What is u if u squared is x to the 6th? X to the 3rd power. How would we do that? We would do a 1/2 root on both sides, or 1/2 power. So a 1/2 power is the same as a square root. If I do it like this, then what am I supposed to do with the powers? Add or multiply? We multiply the powers when we do something like this. If I do 6 times 1/2, I get 3. Okay, next one. What's u going to be? X to the 1/3. Very good. And the next one, what's u going to be? X to the 2/3. Very good. Okay, so this is how we do our U substitution for quadratic in form. Now let's take one of them and do it. I'm going to take this one and solve it all the way. Because there's a couple of steps that we have to take, right? So first step is do the U substitution. I'm going to do u equals x to the 6th. U squared equals x to the 6th, and therefore u equals x to the 3rd. So anywhere I see an x to the 6th, I'm going to replace by u squared. So I get u squared plus 2 times x cubed is just u. Plus 2u plus 1 equals to 0. Now, second step. Solve with u. Is that clock correct? No, I have 1 minute left. Okay. Well, I'll solve this real quickly. So next up is to solve with u. What do I get? I get u plus 1 quantity squared, right? Equals to 0, and therefore u is equal to -1, right? Okay. Last step is switch back to u, or to x. Switch back to x. Well, I know that if u equals to -1, I know that x cubed is equal to u. So if I take the cube root on both sides, then I get that x should be equal to the cube root of u. Can I do that? Use a negative number.
Yeah.
Why is that okay?
Because it's an odd.
Because the root is an odd-powered root. I can do that just fine. So therefore, x is equal to -1. Okay? All right, that'll be it for today. Thanks for your attention.